Welcome everyone to Hardware Meetup NZ Wearable Tech. I'm excited to have you all here. I'm your host, Michaela. So thank you for coming. Who has been to a hardware meetup before? Put your hand up. Whoa, that's a lot more than last time. Yay. Well, for those of you that haven't been before, we've been running these events since 2016. I think this might be our 19th event, or 20th, I'm not sure. And we're all about bringing together people to showcase amazing companies working in different areas in the hardware space. So it's so cool that we've been running this many events. Each speaker, there'll be 15 minutes of me and them kind of just chatting, and then there'll be 15 minutes of Q&A with the audience for each speaker. So we couldn't do this without our amazing sponsors. So first up, we have Loon Digital, an expert engineering team helping you to develop smart, energy-efficient IoT devices. And they also happen to be hiring for an embedded systems engineer, if anyone knows someone or is looking for a role like that. We also have Blender, which is a product design and development consultancy. And then we also have Hudson Gavin Martin, which is a corporate commercial and dispute resolution law firm boasting the largest and most experienced legal team in the country, focused on technology, media, and IP. And last of all, we have Outset Ventures, which is this amazing space we're in, which is pretty great if you ask me. And they're the largest deep tech co-working space in New Zealand. They're always looking for new companies to move in. So anyone interested in desk space or wants to learn more about Outset, you can talk to Matt. All right, so first of all, I have Nikki Reynolds here. Thank you for joining us, Nikki.
Thank you for having me.
So could you tell me a bit about your journey and what your company does?
Yeah, absolutely. I'd love to. So I was born in Canada, but I became a New Zealand citizen when I was 16. I'm a biomechanist by trade, so I went to the University of Auckland and did an undergraduate degree in sport and exercise science, a master's degree looking at gait analysis with children with cerebral palsy. That led me into working in the lab for a couple of years. So getting really deep into the projects that university students were doing in using motion capture before I gained employment at Nike. And I've spent nearly the last 20 years at Nike, initially in footwear. So looking at their products and their new technology from a biomechanical standpoint, using high-speed video to look at heel stability, how much torsional rotation there was, flexibility of the shoe. And then I moved on to working with elite athletes. So my clinical background helped me with assessing the athletes at the highest level at Nike, looking both at how we might modify a product to help them stay healthy and play their sport longer, as well as looking at across whole teams. So looking at foot scans and what are the shapes of feet from different sports and how are they different or the same between sports, looking at women's foot scans versus men's foot scans, looking at the asymmetries that you see in some sports that are handed sports, for example, to look at how our products are best serving them. Then in 2015, I moved on to working in apparel and absolutely loved it. Not a lot of women in the audience today, but working in apparel was really amazing. So the biomechanics of apparel, the most important piece of apparel equipment is the sports bra. And really getting in at ground zero and understanding what women need from their sports bra apparel in terms of support to be able to play their sport better. And then a year ago this month, I started my own company called Dynamic Body Research and Development.
Excellent. Could you tell us about what Dynamic Body Research and Development does?
Yeah, absolutely. So if my slide goes forward. So when I was working at Nike, obviously you have all the equipment that you could possibly want. We have 84,000 square feet of motion capture space with more than 400 motion capture cameras. You have high-speed videos. You have a whole instrumented basketball court, a quarter field of turf inside that you can do testing on at any time, nearly 100 force plates scattered throughout the lab. But what I really wanted to do, like that stuff is great, but it's not you don't need all of that in order to be able to advance a product. And so smaller companies, startup companies, even some of the smaller footwear apparel companies don't need all of this equipment in order to advance their technology. And so it's really about providing big lab expertise to the small labs, the small companies at a better rate, and so that they can play the game with the big guys.
Awesome. Could you tell me about how your service works? Like, what's your process to like get someone from this like concept to actually doing it?
It's not really a scientist presentation without a graph, and I'm sure you tech guys are happy to have a graph. Of course, there isn't a cookie cutter way that a product life cycle works, right? But there is a similar progression, and you guys in entrepreneurship will understand that you start off with an idea, right? And so this first blue line, you start with an idea. There's lots of talking about the idea and lots of input from experts in terms of whether that idea is viable, and putting together, hack together prototypes. Once you get an idea that you think is good, and this is where we're at with Denison, and I just want to say thanks to Denison for flying me over to have this week of amazing first blue line chats about their technology and you know how that could be implemented into apparel, and hacking together some prototypes. Once you get a product that is you know, ready to go on body, then it's about the biomechanical testing. Does it really do what you're wanting it to do? And so there's biomechanical testing to see physically, put numbers to it is doing. And then there's also perception testing. So it's one thing for the piece of equipment to do what you want it to do. It's another whether they actually like it. And then, of course, and this can happen over a long period of time, right? It might be lots of iterations of it to actually get to a point where you're ready to move that forward into a manufactured product, but you're still not ready to go to market. That needs to be wear tested, right? So someone might like that product for the first time they put it on. They might like it for the first hour run they go on, but after 8 weeks, they're like, this is too much of a hassle. I'm going to go back to my previous equipment. And then the last important hurdle is if you want to make a claim about it, right? So if I want to say that my product is X% better than the competition, you better have tested that and have that be able to stand up in court. And so that's a much longer process with a lot more people to make sure that you're statistically definitely that much better than your competition. And so those are the kinds of services that I provide.
Awesome. And what are you pushing towards? You've been running this for a year now.
So the company's been going for 6 months, had a little bit of downtime, but 6 months. And so working with a number of different companies in the US. I have my little lab in the US, but the idea is to transfer now into, come back to New Zealand and set up a lab here. And when I say here, I'm hoping in this Outset Ventures location where there's so much energy and excitement, and working with Denison to provide services to people around here.
Awesome. And are you looking, how can the audience help you in any way? We can have a cool demonstration.
So some of you are probably familiar with Denison, have an amazing technology that is an active muscle, an actuator. That's a really nice way to actuate, to have an actuator on apparel. So it hasn't got a lot of hard parts. We've got a number of things we're looking at, but this audience might have some great ideas for us, and we'd love for you to let us know if there's something you think would be great for this technology. The other thing is, obviously now you know about my services. So if you have a product that you would like to talk to me about, or I might be able to have some words of wisdom for you, or you need some on-body testing, or you want to do some perception testing, feel free to come and talk to me. And then if you have some spare biomechanical equipment you're not using, let me know.
Awesome. Thank you, Nikki. Okay, now we are going to open the floor to questions for the audience.
Nikki, what an incredible career.
Thank you.
How, just stepping back a bit, how did you get your role in Nike? And what are some of the things that when you worked there surprised you the most?
That's a good question. My role at Nike, so I was working in the gate lab or the biomechanics lab at University of Auckland. So the kind of equipment I was using is similar to what they use for sports performance, right? The motion capture, expert in motion capture. I only applied for the job because a friend of mine dared me to. And when I got the interview, I was like, oh, I get to make some friends with some people overseas who do the same kind of stuff as I do. That's pretty cool. And then they flew me over. And so I was like, wow, free trip to the US. Isn't that cool? And then I got the job and 20 years later. In terms of what surprised me most, maybe less of a surprise and more of a eye-opening, you know, just working with that number of biomechanists who have the same focus, diverse backgrounds, but the same focus. It's just an amazing place to work. And every day you come in and the campus is amazing and the people are amazing and the products are amazing and just the experiences that you get to have there is just, yeah, amazing. And I guess I was going with, I got a free trip, so.
Can you give any insight on how Nike progresses, like from that fundamental R&D, how they review against something that they then take into a commercial product? You know, like how that, what kind of, at a high level, what those steps are, what you've got to, the gates you've got to get through to go from research to product?
So the ideas come from all sorts of different places. Obviously, I'm more familiar with what happens in the lab, and there are a lot of ideas that come from understanding the fundamental biomechanics, from talking to the athletes and what they really need. There are a lot of other smart people there who are working on, hey, I've got this really cool material. How could we integrate this into the footwear apparel technology that we have? There is a complicated gating system in terms of, you know, ideas come from all over the place. There's a ability to pitch those ideas to leadership. And so that's a big reduction in the funnel. They do really support people coming with all sorts of ideas. And so there's time set aside for people to do that. And then once it becomes, so from an innovation standpoint, so there's category and then there's innovation. And so they're very separate and they keep them separate on purpose, right? So that you can do innovation stuff that doesn't necessarily align directly with what those categories are going to be. And so then people are working on all sorts of different things that have different time spans to get right. And then once it's, and in terms of the testing, we could be testing something that's a very new, crazy idea, or we could be testing something that's very close to market and is an incremental increase from the previous thing. So, you know, from that perspective, it's the whole gambit from the research lab. Once it's proved to kind of work, a tech pack goes to the category, and then the category will decide how that's going to go to market in their marketing strategy.
What are some of the biggest mistakes you see being made when people are going to develop these sort of biomechanical products?
Mistakes like from an entrepreneurial perspective?
Probably more like development cycle or development approach mistakes.
Yeah, I don't really see that side of the company, because what I will do is have a product come to me and then I test it and I send back the results of that, and then they go away and do whatever they're going to do. So it's not really in my wheelhouse. I would say from my testing perspective, I would make a suggestion about something that would improve a product biomechanically, but it doesn't necessarily align with what they want from an aesthetic perspective. And aesthetics is obviously very important for the customer. And so the biomechanical improvement doesn't necessarily make it into the product. I mean, from a biomechanist point of view, that's a mistake, but I mean, it's a big ship, right?
So aesthetics over function is the big mistake.
From a biomechanical perspective, yeah.
What would you say are some of the biggest areas of opportunity to apply what you do? I can sort of see shoes for high performance, and you mentioned health or avoiding injury, and the sports bra, obviously, and they're also, I guess, a sort of a mass market opportunity. So, doing what you do, where would you say there's value?
From a product perspective, or from a like, how can I provide services perspective?
Well, yeah, maybe it's a bit of both, I suppose, isn't it? Because if the opportunity's there and you can do something with it, then that's the magic.
Yeah, I think from my services point of view is really getting your product onto people early. Right? You might think, oh yeah, this is a great idea. I love it. And this happens in the big companies as well. Everybody's behind it and we've convinced each other it's a good idea. But until you get it onto people, or you talk to people about what that is and whether they want it, you could be spinning your wheels for no reason. So I think that from the opportunities from a product perspective, I'm obviously very focused on bras. That's my passion. And I think there's a lot of opportunity in that space. I think that I would love to work with startups that are on body and be able to work those opportunities more. But I'm not sure exactly what I would be working on.
There's the LEDs on.
And so what's happening with this is, as the LEDs are on, the material is contracting, and that's changing the compression of the sports bra. And so with this, we can provide the support and the comfort when you need it and when you actually want it. And so as you change throughout the day, your support requirements and your comfort requirements change as well. And so we can have a bra and a system that is actually working for you and with you, and providing that support when you actually want it. So yeah, it's really cool.
Awesome.
Yeah, this is part of a dress I worked on like 4 years ago. That's like my first iteration. I can't wear the skirt part because it breaks when I sit down. Yes, but as you can see, in the second one, I strap batteries to my legs, which is a lot more functional than just kind of awkwardly holding it like that.
Very dangerous.
Wouldn't recommend it. Yeah.
Don't do it in the airport.
Don't do it in the airport. Yep. Yeah, so I spoke at a hardware meetup like, was it 2 years ago, I think? Yeah. The dress.
Did you build it?
Yes, I did. Yes. Lots of soldering. I have Steve Leftley here from Myovolt with me. Thank you for joining us, Steve.
No problem.
So could you tell us a bit about what Myovolt does?
Yeah, so I'll tell you a wee bit about Myovolt and then a little bit about some of the ways and journey and how I got here. But so Myovolt's a neuromuscular vibration technology. It's based on a clinical vibration device which is a handheld device. It was generally used for wound healing over the last sort of 30 years. And what we did is we miniaturized some motors and put them into a soft package to make a wearable device out of it for rehabilitation use. What we did is we used some software to control what the motors are doing. They're basically small eccentric load and mass load actuators, and we're using some software to keep them within some specific frequency ranges, which are used for a variety of clinical benefits. And we work with quite a few clinical research universities around the world using this technology for a wide range of medical indications, but also more recently to market, it's used in the sports medicine area as well. So the idea of the technology is it can be put into a garment that can be worn over different parts of the body to provide a very focused neuromuscular treatment on tissues directly under the motors. And it can be basically used as a remote rehabilitation for increasing circulation, reducing stiffness and soreness, and then also there's some nerve stimulation that's used in neurological conditions. So it's been sort of around 5 years of clinical development prior to founding the technology at bench scale, and then now we're just starting to get into some market areas. We've gone through obviously a lot of the regulatory challenges of making a medical device. So it's made in a medical device facility, clean room facility, and it's a low end of the regulatory scale, but still has to follow a lot of the IC processes and CMDR processes for Europe. And we've obviously just been going through all of those challenges to get that out into some reasonable scale, and starting to get it out into the market in sports med now, and then working on some medical areas, which I'll talk to shortly. So that's how it's made. Basically, the device itself is we build all the motors into what's a very sort of soft EVA package. So it's highly flexible. So it's a hybrid soft hard product. It's a bit unusual for some of the electronic factories that we had to set it up with. So we had to set up some quite new systems for gluing and bonding a lot of the materials to provide a sealed package with, you know, motors, batteries, electronics in what essentially looks like a hermetically sealed soft package. And then there's a garment element to it as well, obviously made in a different supply chain, which is body fit and around design for different body parts. And then the module pops into that. But when you see it later on, you'll get that gist.
So what's the journey look like so far?
So this is what our journey looked like. So it's been a while, got a few grey whiskers, so you can tell that the journey here is not from last week. So we started up. So my background is originally a chemistry graduate from University of Canterbury. My first role was working in a textile research firm as an analytical chemist, running GCMS and HPLC and sorts of chromatography, a bit of FTIR and analysis of chemicals. And then I moved into a research team developing chemical finishes for textiles. So looking at adding highly functional finishes on textiles, mostly for industrial partners. So trying to create new dyeing agents and finishing agents and other things that added high functionality to the fibers, so that they could then on-sell higher value products, mostly in the natural fiber segment. But some of the finishes we were working on were electronic. So we started to develop skills in laying different sorts of electronic materials onto fibers. I used to do a bit of work in putting organic conductives on fibers. And we started to look at what electronic fabrics or smart textiles, which wasn't actually a thing back then, what was a smart textile and what could these things do. Had a very free range because I was working as a research scientist, so could attract money from a broad research group and then make some lab curiosities and then show them to them and see how they may apply to their industries. So one of those things that we developed was a pressure sensitive fabric, where we put a series of layers of conductive fabrics together, formed a tight sandwich and turned it into a sensor. And one of those sensors we had some success with and developed it out into some other products and garments. So basically we took a sensor and turned it into a control pad. And the first part of that journey was we put it into a garment for burnt snowboards and created some interfaces with Sony players. And then Steve Jobs saw it and he got us to make some controls for those garments interfacing with iPod, and launched it at his 2003 keynote. And so we got a lot of press from having our technology displayed by Steve on his keynote. And then we decided to like roll those sort of controls out to like a wide range of other garments. And some of those were interesting ones. When you get a lot of attention, you get to play with lots of toys. So I got to make spacesuits and put pressure sensitive remote controls into something called the iSuit, which is ILC Dover's spacesuits for NASA and Johnson. And then we put it into lots of consumer products as well, lots of brands of outerwear, garments, got a few sort of accolades along the way on this sort of technology. So basically we're just pioneering how you could just take one of these lab-based items and just move it into the commercial environment, and where those end users would take you. We didn't really have any brief because we got contacted by lots of companies like automotive companies and interior textile companies, but garments have had a very short development cycle, and you could speak directly to a product designer and say, hey, I've got this cool keypad and you've got a cool snowboard jacket, let's do it. And we just managed to go, and we were able to solve the solution of getting it into their garment. So we could go to their factory and tell them how to put it in, build it for them, and all they had to do was just draw a beautiful picture of it on the sleeve, and we would just go and make it happen for them. So we made it nice and easy, and then we got into some high-end brands doing that, Levi's and Xenia, and so, you know, high fashion sort of players got into it as well, and then some of the very big manufacturers like Decathlon and their brands got into these products as well. So that's sort of where we were when we did all this sort of stuff here. We did a bit of heating technologies as an adjunct to this, so where we put in conductive fabrics into the garments to create heat, mostly for warming garments for companies like Alpine Stars and BMW for motorcycling. And while we were doing that, we were also doing a product with Adidas, which was in wearable controls. But this was coming up to the London 2012 Olympics, and they wanted to add some technology to their athletes' garments that could enhance the performance of the athlete. So they wanted some legal performance-enhancing stuff. And so we took one of our heating fabrics and advanced it into producing some far infrared validated technology that was validated at Loughborough University over in the UK, who was Adidas's validation partner at the time. And we were able to get about 10 to 12% peak performance gains for the athletes when they wore these on over major muscle groups. So it went into cycling initially because you've got a very large major muscle group driving the bike in the quad, so you could get the good effect out of that. And then
legal, and you can get
a totally, as far as I know, completely legal. I don't think Adidas or the British cycling team got challenged on it, but we'll keep the case maybe open. And then it went into athletics as well. And the interesting thing about developing technology is you're siloed under NDA agreements with these teams, right? So we were working with Adidas, developing this technology with them. But we also had an NDA with Australian Institute of Sport, who also wanted muscle warming infrared technology for their pants. So they turned up at the same Olympics, the Australian cycling team and the British cycling team, with the same technology and with different headlines. And neither of the teams knew how the other guys got the shit. So and they found out afterwards, obviously, but it was there was a bit of a PR storm around that. But the Australian and the British teams, they topped all the gold medal tables as well. So it was quite a nice thing. And more recently, we did some work with Craig Walker here in New Zealand as well, and brought this technology is used by some of New Zealand athletes. And I guess this is what led us. So we go back to the pathway of doom. Then so that put us into an area where we're making performance enhancing technology instead of this consumer electronics frivolity. You know, basically, you know, a lot of our electronics were basically in those sports garments. You're at the whim of a fashion designer or a range designer or someone who decides, shall I put this shiny new thing into the garment this year, or what's that other brand doing? And so we wanted to take control of our own destiny. So we thought that, you know, rehabilitation and performance type wearables would be much more sustainable. So we pivoted completely away from all of this and into this. And so the muscle warming technology, it's still used today. It's used out in the US and the Olympic ski team out there. And we still do a little bit of that. But basically, we wanted to scale that up out to a consumer market, but it was too expensive. It was very high power. So there was about 120 watts of heating per pant. And so big battery, lots of panels, each garment. You saw that one with Chris Hoy. So they're all tailored to the athletes as well. So they're highly tailored for each of the athletes. just too expensive, around $1,000 a set. So we decided to pivot to a new technology, and that's where Myovolt came in. So we had been working with focal vibration before for a haptics project for the Dutch military. We developed a vest for the Dutch military for helicopter pilots, which had a haptic guide on their backs, so that when they landed during brownout, they could sense altitude through their backs. And then they had a yaw sensor as well, so it had a cross of different haptic vibrations. So we've been working with vibration for a while in projects like that. So we decided to put that into a rehab context for Myovolt. So that's what led into Myovolt.
That is like a very impressive journey. In particular,
It's a long journey.
I'm like so impressed with how you take like not once, not twice, but 3 times have taken like a cool technology and then just made it like so successful on like a global commercial level.
Yeah, everything's iterative, isn't it? You develop something and then you learn something from it, and then and in the case of the controls, that market went through a bell curve, peaked around 2008, and that bell curve followed. Like a lot of our controls were interfaced with music players and mobile phones. So as soon as the iPhone came out, that cannibalized a lot of the audio player features of the iPod, and a lot of the outerwear designers who were putting our controls into gloves, into jackets, decided to leave those features out. And as people started to use their iPhones more, and so it went through an adoption curve. So we pivoted out into a more sustainable area, but that's part of the sustainability, is that some of these technologies, they come in and out of a technology phase, and you've got to be, if you're nimble, I guess you can adopt to different technologies. So with Myovolt, we used our connections with sort of elite sports that we'd got through Adidas and all these other sports companies, and access to the athletes, and that allowed us to get Myovolt to be used in some of the elite areas here in New Zealand and Australia, and then obviously gave us some elite athletes to kind of validate the technology with their sports medicine teams. So that's what we did from that. And then going back to the Myovolt story, then we've sort of onward licensed that technology out to some US sports medicine companies who don't make hardware, electronic wearable technology, don't have that specialism, allow them or license them to put our technology inside their product, and then they've got market access. So this is a very new relationship we've just started with a company called United Sports Brands, and they own a brand called McDavid and Shock Doctor and Nathan and a few other sports companies that you'll see in Rebel Sport here. But a nice segue on that story is that we're a small New Zealand company with a small brand. We can't get our product into Rebel Sport up against the products in there, which Nike, Adidas, Under Armour, but we can license it to a US partner, and they've got heaps of hooks at Rebel Sport, so our product will go there without the permission. So that's a nice way to get in. We don't have to ask anymore now. It'll come in through McDavid. So what we're working on now is, do you want me to continue on that?
Yes. What are you pushing towards?
So that's sort of sports med use. It's a medical, our product's a medical device. It's a FDA class 1 registered device, and and we're starting to lean much more in now on our research partners that do all the heavy lifting on clinical research with our product, and bring it into some of these medical device areas, which is looking at functional mobility change for people with neurological conditions mostly, and a lot of circulatory enhancement features of the technology as well. We're adding some more technology to it as well, so that you can track data from the device and also carry out functional assessments. So try and create sort of a treatment assessment loop and personalize it depending on someone's problem. These are some of the places that do all that heavy lifting for us. So all that real initial validation research we did back right in the beginning was with Massey University, a little bit with AUT as well, and also some of the circulatory studies we've done at Otago University, and all of the other stuff on that board just spun out from that. So Massey and Otago University published a couple of studies with our device named as the device of use. And then all these other researchers said, oh, we're doing, neurological work and musculoskeletal work using focal vibration, and just contacted us to supply devices. So we just supply them out to all these places, and then they're just publishing papers to show clinical validation in those areas. So we're using them as our go-to-market in that area.
It's pretty good for you guys.
Yeah, so that's the way to do it. I mean, we're not clinical experts. We're hardware engineers, kind of like everyone here, most people here. And so we're using our clinical partners to open up those medical channels for us. And this is an example of one that was just came out in the press a couple of months ago, and that's working with a neurophysiology clinician, and it works with the NHS in the UK, and a rehabilitation clinic, an NHS rehabilitation clinic, using the device for stroke rehabilitation in the outer arm. And those features on that you see there will be built into that stroke device as well. So we'll be able to roll that out to all the other body parts, not just the lower back one. So that's where we're at now.
Oh, do you need any help from the audience?
Yeah, I guess, what I'm really excited about is coming up here and meeting like guys like the Denison team and some of the other like super hardware deep tech stuff that's going on up here. This is kind of this is my tribe in this building. And I guess I'm really, really interested in, this sort of takes up some of my focus, but what I'm really interested now is seeing how some of those learnings on that journey I can help apply to some other hardware companies and try and, remove some of those mistakes that we've made. So I guess really I'm interested in like getting involved in some other companies and seeing how they can bring these things to market using some of the things we've learned along the way.
Thank you so much for joining me, Steve.
It's amazing seeing all these achievements over that period, and I'm just sort of like look at this graph, which is very linear, and this nice curve at the end. But how does because at the start it was sort of like licensing, so I was understand the business model, like how you funded the company, where were there key inflection points with investment around like the Myovolt story, how did you pay for all this?
It's a really good question. So back here when I was a researcher, we would, I was working in a laboratory and providing like technological finishes, and we were involved a little bit in finding industrial partners to fund that research. And we filed some patents on some chemical finishes and licensed some of those. But at that point I was a salaried scientist. So that was how I was funded. And then within that organization, we developed this key piece of IP and sensor technology, and that was spun out of our organization, kind of a little bit like maybe a uni services spin out of Auckland Uni, something like that. Had a small minority stake in it, and myself and the other founder, we developed that whole key part, found the customers in the wearable technology space, and then just figured out that we were in a research organization environment, which wasn't super entrepreneurial, and maybe didn't have the same vision as what we had in the space. So at that point, we went out and got some investment and formed a new company, and that made all these components. So the business model for these are just unit sale components into the company. So, we'd go out to a sports company or go to a technology show, seeing a lot of sports companies in the same location with our wares of different sensors controlled. We built joysticks and keypads and all sorts of washable based componentry, showed them how they could be used in garments through some of our key initial partners. And then we'd go and install, them in their ranges in tens of thousands of units, and in Decathlon case, like hundreds of thousands of units. So we were making some good revenues around that point. And then obviously some of those taper off a bit from that bell curve. And then we're into a new business model, selling smaller, high value units, and then attract some more investment into Myovolt. So Myovolt's a new spin out from that company, and so it's basically a new startup with some new angel investment in, and to raise 3 rounds in Myovolt. Still seed rounds though, so we're still at that low technology scaling point. First license fee deal with that US company, and then the medical device area is still really still exploratory, but like lots of potential.
Right. Awesome stuff. It's quite unusual in this sort of space. When you said you were working for BMW, working on heater pads, how did you approach safety with that sort of stuff? And did you get much of a pushback from sort of regulators and stuff over a product's lifespan rather than when it's just new?
Yeah, that's a good question. So we worked with BMW. We're working with their motorcycle division, and they have slightly different production scale validation than the automotive division. So they're not part of the automotive hardware division. So they're apparel side. But saying that, it still goes through pretty extensive BMW regulatory, CE regulation. It's a 12-volt system that plugs into the motorbike. And so it has to go through a lot of safety testing, but they would be on the hook for a lot of that safety testing themselves and through their own laboratory systems that they had out there as well. So yeah, I mean, this, the path, the sort of the process of getting that product installed. So they had a European garment manufacturer that made it as well. We had to work with them, who had all their BMW rules sets that they had to comply with from head office. But yeah, so it's a whole different process than working with the company making the Adidas pants, which was all made in their development kitchen in Herzog in Germany, at the head office there, and by the development team at low scale, low numbers, lots of more leeway for quality issues than BMW. So yeah, we've worked at both ends. We have worked with automotive companies as well. We did some seat sensors for a company called Tretti in France, and they were just fabric pressure sensors built into an in vitro molding process. So they lay the fabrics and then the sensors, and then they just blow inject really hot foam into the tool, and that we started to look at that type of business area, but that was a very long development path, like you're suggesting, around a six-year development cycle from sampling through to production, and we just pulled away from that because as a startup technology business, you just can't live in that world. Yeah. Automotive's terrible. Anyone here from an automotive company? We've got some from Rocket Lab, but they turn around way faster.
Perfect. Thank you so much for joining us.
Thanks very much.
Alrighty, so now is pitching time.
I have a really weird request. It's not really a pitch. So I'm Sav. I'm a product manager at Limetry. We make electrodes that measure the electrical signals of the gut to be able to diagnose gastrointestinal diseases and disorders and conditions. We're looking for an introduction to that guy that's reverse aging, Brian Johnson. Can anyone help us? Really weird request, but if anyone has any tips, come and find me. Thank you.
Thank you. Hi, my name's Grant. I'm from Synovus Technology. I've got a request for you as well. We're just in the middle of validating a new platform product name, and we'd really like some feedback from people, please. So I've got some cards here with a little QR code on them that'll give you access to the survey. There's only 6 questions in it. Take you a couple of minutes. You can do it on your phone if you want to, but any information you could give us would be very much appreciated. Thank you very much. Just grab a card from me, and be love to hear what you've got to say. Thank you.
All right, and next up, we have our last speaker, James from Earshots. Welcome, James.
Thank you. Thank you. Nice to be here, everyone. Good to see all these very clever faces. So I think first and foremost, Earshots exist because as a team, we're really passionate about elevating the magic that exists between music and sport. And I think everyone will know, everyone's watched their favorite highlight reel of their sport, you know, whether it be rugby or soccer or whatever, and what music does when you hear it over top of that, all the way through to, you know, if you're a runner or an athlete and you love listening to music while you're doing those activities. So that's what drives me. That's what gets me up in the morning. That's what I'm passionate about. From a, you know, what is our role in doing that elevation? So we have many 10 years ago, actually, I had the idea for this product around this whole theme. And basically, what I was sick of was riding my mountain bike, doing trail running, and headphones falling out of my ears or constantly moving. And if anyone does a lot of those sports, they'll know about flow. You know, when you get into a flow state and then something interrupts you, like a pair of pain in the ass headphones. So I decided that there had to be a better way to do that. And so we came up with the Earshots product. I'm not going to talk about headphones per se, because there's lots of those. I'm just going to talk about what's unique about us. So we developed a new system that we call MagFit, and MagFit uses the natural polarity of gel-coated magnets to hold the earphone securely to your ear. So there's a magnet in the earbud, and there's a magnet in the hook that goes around the back of your ear. That's how we went about solving this problem of earphones moving and falling out. So you get a beautiful fit. It's movement proof, it's sweat proof, it's waterproof, and it helps also with a few other things that I'll talk about later. But yeah, that's what we do.
Awesome. That's pretty cool. How do your products work? Like, how are they made, I guess?
Yeah, cool. So I thought rather than talking about manufacturing, which you've seen a lot of the photos from Myovolt, stuff like that, I thought I'd talk about MagFit with relation to this. So there's kind of 6 areas that MagFit needed to, or I guess 6 variables that we needed to figure out in order for MagFit to work. You know, how do you use magnets to attach something to your ear? So obviously within magnets, you'll know there's different magnetic materials. So we have to work through what, you know, material is best. Magnet form, aka what shape do you use of those magnets? How do you fasten them into a body, essentially, to stay in place? What angles do you use? Because it's not just about, you know, there's a whole lot of inertia and movement that occurs when you're moving. And so how do you make sure that you're using the magnets, but it's not actually just flopping around on your ear? What strength do you use? And also, how do you manage the audio performance? So you'll all know that a speaker driver or a driver uses magnets to drive the diaphragm. And so how do you make sure that you don't interfere with sound when you put a magnet right next door to a driver? So these are all the things that we've had to work through to make a product like this.
What does the journey look like so far?
Journey, yeah. So there's 2 slides I did for this. I thought I would start with this one. So just so where we're up to. So I had the idea for Earshots 10 years ago. It took me 5 years or so of my own R&D to figure out how to make MagFit work. We launched technically our MVP in April 2020. And then in April 2022, within COVID challenges, we made some improvement. So, you know, we're at this stage here. In terms of getting there, you know, like, this is me with hair, this is me with no hair. You know, it's been a journey of commitment. And because no one had done this, there was nowhere to turn for support. So it was really between myself and some of the other team members. There's actually one here who's been involved in designing and developing MagFit. You know, it's just been a lot of hard work. But, you know, I know you saw that beautiful straight line from, was it Steve?
Yeah.
Yeah. It probably looks a little bit more like this, would you say? Yeah. You know, I use this as a trail running elevation map. You know, anyone who does a bit of running knows that there's uphills and there's downhills and there's pain and there's enjoyment. You know, we've been a bit up and down, but I think we're now at the start of something really exciting. So, you know, I see us hopefully there'll still be a little bit of downs, but they won't be as big. Yeah, it's been a heck of a journey. Bit of context, I've been involved in starting startup accelerators. I was involved in Sprout Agritech, getting that off the ground many years ago. I've seen the playbooks, I've taught the playbooks, and the playbook should be thrown in the bin. So yeah, it's been an interesting journey, but that's probably a whole session for another chat.
Oh, the part that's in your ear is connected to the magnet that goes behind your ear.
Yeah, so essentially there's a magnet in the earbud itself, and then there's a magnet in the hook that goes behind the ear. So it's magnetizing through that back part of your ear. And the reason we chose that is because actually in that area is a really, really stable piece of cartilage, essentially. So if we knew if we could clip something to it, it would work really well.
So it's like, is it slightly flexible as well?
Is it slightly flexible? The material?
The overall, like the arch part, I guess, is that flexible to like bend? Okay, cool.
Yeah, totally. And just to add more context to that journey, so yeah, MVP, this was all about proving that we could combine MagFit into a wireless earbud. There's a whole lot of risk around, will these magnets interfere with wireless connectivity, with Bluetooth, with audio, all that stuff. When we made this product, I just didn't even care. I just I went, there's a journey for us on how we build these, but this was built essentially like an OEM model. I went to a headphone company and I said, hey, I've got this idea for MagFit. Can you put it into a headphone? So we didn't do any development on anything else other than just the MagFit. That was the beauty of how we got the business going quite quickly. And then the next version, there was a lot of interesting feedback. I think I mentioned when we spoke that, everyone says, oh, launch a product you're going to be embarrassed by and all that, blah, blah. What they don't say is, well, what do you do with all the customers that are pissy with you, who've paid money for a product they don't like, And so if you need any help with that, come see me afterwards. But we took on board customer feedback and we've done this version.
And what are you pushing towards, I guess, which is?
Yeah, so we haven't shown this to anyone, so I wanted to show you guys because you're all hardware enthusiasts and a bit of a first peek. But we've been on this journey of evolution and figuring out how do we miniaturize this product, how do we deliver overall a great experience within our unique selling proposition. And so we are on the cusp of launching a new model, which looks a little bit like this. And so I've been really fortunate on this journey to meet great people. So we're a fully remote engineering team. We have acoustic engineering in Japan, mechanical engineering in Philippines, electronics in Franz Joseph. And so, manufacturing in Shenzhen. But this is a culmination, and I think Steve mentioned earlier. It mentioned the learning, the cumulative learning that you get, this is a culmination of 10 years of hard work and commitment. But I'm super excited by this product. It'll be the best sport headphone you've ever experienced. No word of a lie, these sound better than what you'll get out of a Bose. You might say, how do you do that? I'll tell you. In here, so acoustics is, there probably are people who know more about acoustics than I do. I'm spouting off from our acoustic engineer, but we've got a 13mm driver in this thing. Because as an earbud, we're not putting all the electronics in the earbud itself. It gives us more space to put a huge driver in there. So for a tiny earbud, you get a better audio experience than anything else on the market. So I've actually got a sample with me. I'll find a quiet area at some point, maybe at the end, and people can come and have a listen.
Love that.
Yeah, that is what we are driving toward.
Can you tell us when this might be released then?
Yeah, we have a release window for this product. It'll be later this year to early next year.
Awesome.
We're working on a few go-to-market launch partnerships, so it'll be predicated on how those partnerships pan out.
Well, I'm looking forward to seeing it then.
Yeah.
Cool. And is there anything the audience can help you with today?
Look, we're a really fast evolving and expanding company. So I just came here today because I was aware of this community and wanted to engage and say, hey, we're here. We're looking for great people. If this is a space that, you are interested in, and you are, you've got to be a little bit brave to take on consumer electronics. And, there's a differing strategies. Listening to Steve, he's got a strategy around his IP, his partnerships and licensing. I'm going for the strategy of, I want to be the guy that does the licensing in the future. So if you like big challenges and that type of stuff, then come and talk to me.
Awesome. Cool. Thank you, James.
Cool.
Sweet. Now we will open the floor to questions.
What's the normal size of a driver in normal earbuds, like AirPods or something?
Yeah, so your AirPods will have about a 10mm driver. Yeah, so we're a 13, so about 35% more. And it directly correlates, driver side directly correlates mostly to your mids and your bass. So the better, you're going to get better bass out of a larger driver.
It seems like a really crowded market space to move into with a lot of players and, you know, different sort of tech features and so on. And you started saying you wanted something that would stay in the ear, right, through a lot of sort of pretty intense activity. And now you're telling us there's better sound. You know, how are you going to show people what's going to really separate you out? You know, what is it about those ideas that's going to market this thing? Because I mean, it sounds really interesting, right? I'm like, oh, I want to try that for sure.
So I've done the job then, haven't I?
Yeah, but
what's the question?
I guess maybe it's the move. Originally, it was really an emphasis on you're out there doing stuff, right? And it would keep falling out of the ear, and then later on, it's the proposition seems to have moved a bit.
No, I didn't say the proposition had moved. I just said that, you know, if you look hard at what a customer values, right? Yeah. So in audio, and when a customer decides I want to buy a sport headphone product, right? When our research has shown us that when they differentiate between a sport headphone and everything else, what they're really saying is, how does this thing fit to my ear? Right? And so what we've done is created a highly differentiated offering called MagFit that differentiates. So when you go up, if you can imagine going to a Harvey Norman, and I've watched people do this, they're like, what are the difference between all these things? And the store people are like, oh, this one's in the ear, it's got this one's not, you know. Yeah. Whereas this guy's going to be able to say, well, these ones have got MagFit. Oh, what's MagFit? Oh, it's this unique magnetic system. Oh, shit, I've never heard that before. Let me try that.
Right. Yeah.
And then what I've done is I've said, right, it can't stand on MagFit alone, because the number 2 thing the customer wants is audio quality. Right. So what I'm saying is I've hit the first thing, and now I've hit the second thing, and the rest is history.
Yeah. And I know what you mean about the first point. I mean, I've run and biked and all that stuff, and it's annoying as hell, most products out there.
Yeah.
Or you have a good one that doesn't work when you do that. You know what I mean? Like, it's great when you're sitting down, but you really want that. But you can't have it when you're out there doing sports stuff. So, yeah.
I think also just, you know, there's been some reasons I've stayed committed to this journey. I know you talk about a crowded market. What's scarier about a market is if it's a monopoly, right? But when I say to people, who's the number 1 sport headphone company in the world? People are like, don't know. So no one owns it. That's a scarier market. So we've been able to get into the market because there's no one big player. And that's how we've been able, and we've done, you know, we're up to now kind of maybe at just over $3 million in sales of the 2 models. And that's just the basic stuff that we've done. So, you know, it's how you look at those markets is really important, and how you decide what you're going to go after.
Cool.
Just wondering how you've gone out about protecting the IP protection on the product side of things. What sort of things you've done there? If you look like you've got design, patents potentially.
Yeah, we've got it all. Yeah. So we have a couple of patents now. So as we've got a core patent over our MagFit, and then as we've refined the technology, we've just added more patents to those innovations. So we've got that, and so we'll keep doing that. And then for each of these models, we've had design registrations. We've got a trademark on Earshots globally. We've got a trademark on MagFit globally. So yeah, I've really really gone into everything.
Yeah, cool. Relating to the other question, I just bought a pair of AirPods, and every time I like smile, it just falls out of my ears. So I really should have thought and just waited like another week until I met you.
What have been your biggest challenges in this business to consumer kind of landscape?
And there's been so many challenges. Like as I said, Tom down here, I used to work with, he's seen a few of them. The biggest challenge, honestly, is probably an emotional one. You know, the grit to stay at it. And this is 10 years. And I was just saying to Tom earlier, I think I mentioned here, you know, it's taken me 10 years to really realize the vision. You know, those other two products, those ones there, you saw them. I wasn't super proud of those products but I knew I had to sell something. But now the product that we've got that we're going to launch, I'm like, I've done it. I've realized the vision, but it's taken 10 years. And so sticking at it, committing to me is the hardest challenge.
I guess as a follow-up on that, can I ask you kind of started designing this for yourself. Is that still the case, or are you taking on a lot more customer feedback, but still have a large influence on what you want to do?
Yeah, so in terms of how we manage, if we talk about how we manage our roadmap, like our product roadmap of features, what we talk about as a team is trying to merge your own vision as a team, because all the team members have ideas. You're trying to merge the vision with what your market, what your customers want. And so we now have these two funnels of information coming in. And I think my role, I guess at the moment, is like a product manager. And so I'm trying to manage what do the team want to do and what do the customers need. And I think that's the job of a product manager, is to do that really well. So I still have ideas. I've got a lot of ideas, but those have got to be balanced alongside with what the market's telling us and what the rest of the team want to do as well. Does that answer your question? Yeah.
Can we just hand the mic down?
Any consideration of the military market?
Yeah, there's consideration for other applications. We, on the licensing thing, because that would be kind of like a licensing probably. What we decided was that we needed to have a brand and a product that we tested our technology in. And so we've chosen to do that in sport audio. And that's allowed us to get to where we are and refine the technology. Now that we've really nailed it, we'll start to look at how we might, in other categories where we don't want to build products, we might license it out to other players to build products with our IP.
That's a really good application for that, actually.
It seems like there's a lot of things here which can both be simulated on a computer, or you can iterate and just create test products and stuff like, air fit, magnets interfering with drivers, and a lot of acoustic stuff. You can simulate it, but the simulations are not always right. Have you found, any areas where the traditional approach of either simulating or iterating, it has produced bad results? Or do you have a preference for an approach to that sort of R&D?
I mean, our use case is very specific. So I don't want to, whatever I'm saying, I don't want it to be viewed as I would say that across all context. But I'll give you an example, right? So we have a new mechanical engineer who's came from Logitech, and he was part of a company called Jaybird that some of you might know. He came along and he said he had these model ears, exactly kind of the simulation thing, right? And he had thousands of these things, and this is this percentile, and this is this percentile. And what was interesting was he's made every single decision based on that simulation. And we've made a product design decision in Gen 3 where, what am I trying to say here? You have to mix the two. You have to do both. Because simulations only get you so far. Sorry, that was a roundabout way. We ended up in this huge argument with him because his ear models didn't account for a particular part of how the ear works, but he was convinced that his ear models were absolutely dialed, and they'd used them at Logitech. I said I didn't want to say it, but I was thinking that's why most of the headphones suck. But I haven't had the guts to say that to him yet. But yeah, sorry, I don't know if I answered your question. I think you got to do both.
Yeah. Cool. We've got a question online here from Samantha. James, could you share more detail on what you did with your first piece of investment money after garage development stage? And was it the most valuable choice looking back?
Yep. So I got this product. What I did, and what I'd encourage everyone to do when they're starting a business, is figure out what is unique about what you're doing. What is the number one thing? You have to choose one thing. So what is it? And then once you've got that, you can generally validate that relatively cost effectively. Obviously, there's a continuum to that. But once I did that, I funded that to the point where I knew that MagFit could work. And then I went and got a small amount of money that allowed me to go to a factory and say, okay, can you turn this into a product? So that first amount of money, which is probably about 150K, that got us to production of our Gen 1 product. And that's how we used it. So that first amount of money got us to market. It wasn't a first amount of money to do some R&D. I hope that answers the question, whoever that is.
You mentioned before about, you can have more driver in the ear because I guess you've got more stuff in the hook, right?
Yeah.
Have you considered what additional capabilities or compute or whatever that you could put in there? Because I guess with MagFit, it seems like you can hang more off people's ear more stably. So have you thought about doing more than just audio?
I think you probably got some ideas by the sounds of it. Yeah, I think the short answer is yes, and it's super exciting. And hopefully, one day we'll be able to show those ideas, but I think they're a few years away yet.
You two should have a chat. Time's up.
I guess how much effort and how complex has it been getting the distribution into retail, or is it all online sales?
So in New Zealand, we started off as a direct-to-consumer business, but that was primarily because of COVID. Like I literally quit my day job 3 weeks before COVID locked everything down. Super scary. But we're in New Zealand, we're in Torpedo 7 and Evo Cycles, plus a couple of independents. We have a distributor in Australia. We have a couple of independents in the US, and we sell online as well. I'm probably unique because in the context of this audience, only because my background is actually sales and marketing. And I've had to learn about product development and about engineering. And so the sales and marketing side is a little bit second nature to me. I'm fine picking up a phone, setting up a pitch, just going and doing it. So I haven't found it hasn't been too difficult. And again, I think another big reason why I've stuck at it is we've still got something globally unique. And when and everyone out here who's working on something, if you know what is unique about what you do and why you've done it, you'll find you can get a first meeting with anyone. And that's what's exciting about this is I'm setting up more meetings in other countries at the moment. I can still get in the door straight away. Well, what do you do? I've got this unique MagFit thing. Oh, I never heard about that. That's cool. Come and have a meeting. So yeah, we're still able to leverage that, and that's making things, it's not easy, but it's not like I'm having to bang down doors to set meetings. Yeah.
Mm-hmm. Cool. Awesome. Thank you for
Thanks, everyone.
sharing all your amazing stuff with James, to Outset Ventures for allowing us to use this amazing venue, to Blender, to Hudson Gavin Martin, and to Loon Digital. Yeah, without you guys, we could not hold these events.